networking devices are nothing but the products which we are going to use to connect various networks. So the various internetworking devices that are available are hubs, switches, repeaters, bridges, routers and gateways. In our syllabus we are having repeaters, bridges, routers and gateways. So we are going to discuss about repeaters, bridges, routers and gateways. So before going to discuss about these repeaters and bridges, let us see what is the purpose of the internetworking devices. So these internetworking devices allows number of nodes to be connected to the network, and also they will extend the distance for which one network can extend, and they will also control the traffic, and they can merge the existing network. Let us see what is a repeater. So at which level we are having in OSI model, we are having 7 layers are there. In 7 layers the repeater will work at OSI's physical layer. So what is the purpose of the repeater is, it will regenerate the signal strength. So whenever we are going to pass the data from center to the destination, what is going to be happen is, in between the signal strength is going to be weakened. So if the signal strength is weakened, the data is not going to be received properly. So to avoid that problem, what we are going to use is, between the sender and the destination we are going to use repeaters, and this repeater will amplify the strength or will regenerate the strength of the signal, and then only it will pass the data to the destination. With that, it is not we are not going to lose any data. So repeaters are used to regenerate the signals. So if we are using only amplifiers are also used to regenerate the signal, but the problem with the amplifier is it will add the noise also into that. Whereas if you are going to use repeater, the noise is not going to be added, only it will amplify the desirable signal and it will pass to the destination. See, let us see. We are having two network segments are there, network segment 1 as well as network segment 2. If we want to pass the information from computer A to computer E, if computer A wants to send one packet from A to E, in that case what is going to be happen, it will pass the data over this network, and once the data has been reached here, the strength of the signal may be reduced. So what we have done is, we have used one repeater. This repeater will increase the strength of the signal, then it will pass to this destination address. So that is the use of the repeater. See here, whenever we are going to transmit our data, see the strength of the signal has been gradually reduced. So if once it reaches the destination, means it will not be possible for us to get any information. So we have used one repeater. Repeater has regenerated the signal and it has transmitted the information to the destination. Where we are going to use this repeater is, whenever we want to transmit our data over longer distances, in that case we have to use these repeaters. And next we are going to discuss about hub. For what is the purpose of hub is, so see here, we are having for example 20 systems are there in our lab. If we want to connect all these 20 systems together, in that case we are going to use hub. So we are having assume that we are having A, B, C, D, E systems are there. If you want to connect all these systems together, so only with the help of hub only it will be possible for us to connect all these systems in olden days. So hubs are not intelligent, because whenever we have transmit one packet, what the hub will do is, it will transmit to all the nodes that was connected to the hub. So whereas in that case what is going to happen is, every node will check that whether that packet belongs to it. If that packet belongs to it, then it will utilize that packet, otherwise it is going to discard the packet. Instead of hubs, we are going to use switches. Switches are more intelligent than the hubs. What switches will do is, switches will send data only to the destination address. Instead of hubs, nowadays we are going to use switches. Now we are going to see about bridges. Where the bridges will operate is, it will operate at the data link layer. So whenever we want to connect the systems within the building, then in that case we are going to use bridges. What the bridge will do is, if we are having a large network was there, if we want to divide that large network into smaller sections, in that case we are going to use bridges. If the bridge believes destination address is on the network other than from which the data was there, then only it will forward that packet to the other network. If address is not there on the other side of the network, the bridge will block data from passing to the other network. So see here, this is segment 1, and this is segment 2. We have connected these segments through the bridge. Assume that these are all the systems that are available in our BCom lab, and these are all the systems that are available in BSc lab. We are connecting these systems with the help of the bridge. So within the building, if you want to connect various systems together, we are going to use bridge. So if we are using more than one network, to connect those networks, we are also going to use bridge. So what the bridge will do is, it will make sure that data traffic is going to be controlled and collisions will not occur whenever the data is going to be passed from one network to the another network. Bridges will analyze the incoming packets and forward the packet based on the addressing information. It will collect and pass packets between the two network segments, and also it will broadcast the packets to the networks, and it will maintain the address table. So whenever we have transmitted a packet through the bridge, first it will check in the address table whether that packet belongs to the same network or to the other network. If it belongs to the other network, then only it will pass the data, otherwise it will not forward that particular data. So bridges are used to join two similar types of the networks. It is used to join two similar types of the networks. Now we are having gateways. What is the purpose of gateways is, gateways are also useful to join two networks, but here we are going to join two dissimilar networks. Bridges are used to join similar type of networks. Gateways are used to join two dissimilar networks. So it is nothing but a network node that connects two networks using different protocols together. We are having several protocols are available. So we are having two different networks which are using different protocols. To connect those type of the systems, we are going to use gateways. So where the gateways are going to be implemented is at the transport layer of the OSI model, and it is also used to convert protocols among the network. If a packet is forwarded to one protocol, it will accept that packet and converts it to another protocol. So gateway is implemented either by the software installed within a router, or can also be implemented by the hardware, or both. What are the types of the gateways? We are having different types of the gateways are there. Network gateways, protocol gateways, and tunneling gateways. What is a network gateway? Multiple networks using similar network layer protocol are connected using network gateways. That means we are connecting similar networks having the same, they are following the same protocol. Example of the network gateways are routers. What is a protocol gateway? So it connects networks using dissimilar network layer protocols. So that means different types of the networks we are going to be connect, different types of the protocols we are going to. That means one source is using TCP/IP protocol and destination using another type of the protocol, like IPX or SPX protocol. In that case, if you want to connect those networks, we are going to use protocol gateways. And tunneling gateways. What the tunneling gateway is used is designed to transmit the data packets from one network to another network. What is going to happen here is between two dissimilar networks we are going to connect. For example, if you want to say that some communication is going to be transmitted between two people. One people knows only English and another people knows only Telugu. So in that case, what is going to happen? The person A doesn't understand Telugu, whereas the person B doesn't understand English. In that case, what is going to happen is some conversation is going to be taken place. So some mediator, that mediator will translate the language. So whenever the sender has sent the data in the form of English, what the mediator will do is that will transmit into the Telugu and it will forward it to the destination. That is how the tunneling gateway is going to be done. Data packets of source networks are encapsulated with IP in such a way it is identified only by the destination address. See in this diagram, we are having two networks are there which are using different types of the protocol. The first network is using TCP/IP protocol and second network is using IPX or SPX network. In that case, what is going to happen is a TCP/IP network is going to pass the data to IPX or IPX SPX network. In that case, what we have used a gateway. what the gateway here has done is it has done tunneling. It has done tunneling, and here the conversion has been taken place. Though the packet has been forwarded in the form of TCP IP network, the conversion has been taken place in the form of IPX or SPX, and this gateway will encapsulate this TCP IP with IPX SPX and then transmit the packet to the IPX SPX network. TCP IP network needs transfer data to IPX or SPX network. In that case, source network encapsulate data packets with IPX or SPX header and trailer. Whenever we are going to send data, for each packet we are going to send header and trailer information. So here we have encapsulated, this network has encapsulated IPX SPX header and trailer with this packet, so that destination network will recognize the data packet and will utilize that particular packet. So who is going to encapsulate that, who is going to decode that particular encapsulated data? Router is going to decode the encapsulated data, and packets before transmitted to the destination node in order to retrieve original data packet. Now we are going to discuss about router. Router is nothing but it is an interconnecting device. It is used to connect various networks that uses different technologies and different media. So these devices pass data packets between networks based on network protocol, based on different network protocols. It will operate in network layer of OSI model. So routers have the ability to take decision. If suppose if we have passed data from source to destination, router will select the best path for the delivery of the data on the network. So between networks of various cities, if we want to pass the information, in that case we are going to use routers. Suppose if you have want to send some information between Chennai to Hyderabad. Chennai to Hyderabad, we are having several routes are there. We can reach Chennai to Hyderabad via Vijayawada, or we can reach Chennai to Hyderabad via Guntur, or we can reach Chennai to Hyderabad via Bangalore, or we can reach Chennai to Hyderabad via Tirupati. So what the router will decide is what is the shortest path or what is the best path, what is the less traffic path. It will select that particular path, then only it will transmit that path to the destination. That is what router will do. So let us discuss about the summary of this information. First we will discuss about hub and Ethernet switch. It is used to connect different computers in a computer lab. Bridge. Coming to the bridge, lab in one building is connected with lab in another building. Hub, switch, bridge works in the data link layer. And now router. If you want to connect our entire campus to the outside world, in that case we are going to use router. Internet service providers will maintain the router. Routers will work in the network layer.